SP2018 scientific notation. Good. All right, scientific notation. Well, what is it? It's a number times 10 to a power. A times 10 to the nth power. So that A, though, has some rules about it. It has to be between 1 and 10. It can be 1, but it cannot be 10. It's got to be like 9.999, something like that. Okay, it cannot be 10. So between 1 and 10. This exponent here could be positive or negative. Okay, it'd be a plus if a big number like 84 million is a big number. So it'd be a positive 6. Or 8.4 times 10 to the positive 7. It'd be a minus if it's like a really small number, like 0.8 zeros and then an 84, and something like that. All right, so we're going to work on moving first from standard form into scientific notation, and then we'll go the other direction, and then we'll do some operations that allow us to use our exponent rules. Okay, so first let's write the number in scientific notation. Okay. All right, so 1,350,000,000. It's a pretty big number, right? Yeah, I'd love to have that. That's how much I make a year.
I think everybody makes that. About
a tenth of, it's closer, right? That's a little still way too much. But anyway, take about all those zeros off. That's what I say every month. Okay, here we go. So big number. So when we change this into, I get paid once a month, so that's what I say when it goes to the bank.
Oh, you only get paid.
No. Yeah, you can look it up online if you want to know. All right, so this is a big number. So when we write it in scientific notation, the exponent on the 10 is going to be positive or negative. Positive, because it's a big number, right? So where does the decimal need to go when we put it in scientific notation? Between what? Because it's right here to begin with. It needs to be between 1 and 3. So 1.35. The reason it needs to be between 1 and 3 is because we need that number that's in front for scientific notation to be between 1 and 10. So we're just going to move this decimal to where it's there, and we're going to count how many places it moved. So 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So that's times 10. No, because 13.5 is not between 1 and, yeah. We'll close it in just a second. All right. Let's look at this one. Is this a big number or a small number? Small number. So we know it's going to be a what kind of exponent on the 10? Negative. Okay. Where's the decimal going to go? Between the 3 and 7. Right there is where it's going to need to be. So that's going to be 3.75. And then I'm going to count how many places I need to move it. 1, 2, 3, 4, 5, 6, 7. You should have. It would be a negative 7 because we're taking it's a small number. Okay. Yeah. Well, hopefully it gets a little bit more complicated, but not too bad. Oh, it won't get too complicated. The thing you got to remember is if I'm taking a big number and making it smaller, I add to my exponent. Okay, so like when we start with this original problem, we're starting like at 10 to the 0 power, and then we move it 9 places to the left. That's adding 9 to 0. Mason?
I got it.
You got it now? Okay, all right. Here, if we're taking a small number and making it bigger, if we're moving the decimal to the right, we're subtracting from our exponent. So we're starting at 0.000000375 times 10 to the 0, and I moved it 7 places to the right. That's -7. Okay. So if I move left, I'm adding. If I move right, I'm subtracting. When I'm taking a number from not scientific notation into scientific notation. If you just understand, make sure you put the decimal where that number that's out front is between 1 and 10. Then count how many places. That's all. If I'm moving it to the right, if I had the decimal started here, I needed it to be right here. That's to the right. If it's going left, it's going to be positive. If it's moving to the right, it's going to be negative. That's what we want to do. Caleb, can you go close the door for us? We're all shivering, so. And to me, it feels great, but that's okay. Right. Okay, so here we're going to go the other direction. We're going to start with the number that's in scientific notation, and we're going to write it in standard form. So let's start with like 1.65 times 10 to the 5th. Okay, look at the exponent on the 10. Is it positive or negative? Positive. So that means this is going to turn into what kind of number? Bigger number. Okay, again, positive exponent. So to undo that, we're going to move it 5 places to the right. So which adds how many zeros? No. Doesn't add 5 zeros because these 6 and this 5 take up 2 of the spots. So there's only 3 left, right? 1, 2, 3. Adds 3 zeros. So 165, 165,000. Okay. So if we're in standard form or in scientific notation, we want to go to standard form. Positive x. We started in scientific notation. We're writing the answer in standard form. If it's a positive exponent, you're going to move the decimal to the right and get a bigger number. All right. If it's 7.63 times 10 to the -4. So it's a negative exponent, so that means it's going to be what kind of number? Not a negative number, but a little number, okay? So if a positive exponent moves the decimal this way, negative is going to go the other way, right? So how many zeros are we going to put in front? 3 of them. 1, 2, 3, 4. So the new decimal, 0.000763. That's the standard form for that. So you fill in the empty spots with the zeros. Let's do another one. Just get to practice. Let's say we had 4.8 times 10 to the good number. Okay. What's that gonna make a bigger number or gonna make a smaller number? Bigger. So that's gonna move the decimal to the right 6 times. And if you want to go over here and do it this way, to be in scientific notation, it does, not in standard form. So it's adding 5 zeros. 4,800,000. Okay, change that to red. Let's say we had 1.85 times 10 to the negative 2. Which direction do we move the decimal? Backwards to the left 2. 1, 2. Put a 0 in its place. So 0.0185. So for starting in scientific notation and moving to standard, that's the way you're going to do that. No, this is not it. No, there's not much you catch. Multiply. Okay, so we're going to take two scientific notation numbers and multiply them together and write our answer in scientific notation. All right, so we got 1.5 times 10 to the 9th times 3.0 times 10 to the negative 6. Okay. Now, some people will tell you, hey, put that in standard form, each of them, and then multiply, and then put that answer in scientific notation. Well, that's all well and good until you try to type that number into the calculator. It won't fit. Your calculator can't handle that number. It can only do 10 digits long. That's more than 10 digits. It's actually 11 digits. Just one too many, okay? This, it could handle that, but you're stuck because this won't work. So you got to know some rules. We're multiplying everywhere in this thing. Is there anything that has the same base?
Yeah.
What?
10.
The tens. What's the rule for the exponents when you have the same base and you're multiplying? You add them up. So these two together make 10 to the 9 plus negative 6 is 3. And then we're going to multiply these numbers in front. Just multiply them out regular.
You add 9 to negative 6.
I did. Yeah. This 3 came from 9 plus negative 6. That's where that's coming from. Okay. And now I wrote that out there. You know, I would expect you to just go ahead and multiply it, right? So I'm going to multiply 1.5 times 3. 4.5. So 4.5 times 10 to the third. Then I'll look at it to make sure it's true scientific notation. What's the rule about this number in front? It's got to be between 1 and 10. It's 4.5 between 1 and 10.
Yes.
We're good then. We're done. You could. What if you did? 4,500. Yeah, good job. 4,500. So there's standard form and scientific notation for that. We'll get there. Caleb asked a great question. Let's address it on this equation or this problem. 8.5 times 10 to the second times 1.7 times 10 to the sixth. All right. It's multiplication, same as the last example. What can I do with my tens? Add them up. So that'd be 10 to the 6 plus 2 is 8. Good job. And then in the front, I'm saying 8.5 times 1.7. Just doing the regular multiplication with that number in front. 14.45 times 10 to the 8th. Uh-oh. Why not? That's not between 1 and 10. So what have we got to do to that number to make it between 1 and 10? Got to move the decimal between the 1 and the 4. When I do that, what does it do to my exponent? It makes it a 9. So if I move to the left, I'm taking a big number and making it smaller. It's just like example A. I add how many places I move it to the exponent that's there. So I'm going to add 1 to that. That'd be 1.445 times 10 to the 9. And then you could convert that to standard form if you needed to.
Are we gonna have to do it?
On some of the problems, it may ask for the answer in standard form. Most of the ones where you're just multiplying like this, you want the answer in scientific notation at the end. There's a couple of word problems that ask for in both forms, actually. So, all right, not too bad. So if we move it to the left, it adds to the exponent. Pluses every how many places I move it. All right. Let's say we had 2.5 times 10 to the negative 5 times 0.05. Yeah, I know that's not scientific notation. Doesn't matter at this point. And 10 to the third.
Did you say you add the exponent?
If I move this to the left,
No, I'm talking about like that.
oh, when I multiply, yes, you do add the exponents. That's right. So that's going to end up being 10 to the negative 2. Negative 5 plus 3, negative 2. Then I'm multiplying 2.5 times 0.05. That's going to turn that into 0.125. Let's check it again here. 2.5 times 0.05. Fairly certain that's right. Yeah. 0.125, which is that scientific notation? No. 12 cents is not between $1 and $10, right? So we got to make it that way. Where's the decimal need to be? Between the 1 and the 2. Because if we move it between the 2 and the 5, that's 12. That's bigger than 10. So we're moving one place to the right. No. I would subtract 1. If I move to the right, I'm subtracting. So that'd be 10 to the negative 3. Negative 2 minus 1, negative 3. How can you check that? Well, think about what is standard form for the purple one. I would move the decimal to the left 2 and get 0.00125. On the red one right here, if I move the decimal to the left 3 places, do I end up with the same standard form number? Yes. That means it's correct. Okay. So if we're moving to the left, we plus every how many places we move. If we're moving to the right, we minus every how many places we move. Shouldn't usually have to move more than 1. Sometimes that could happen, but it's not very often that you're going to move more than 1 either direction on a problem like that. Got 1.06 times 10 to the negative 4. 1.05 times 10 to the negative 3. So it's going to be 10 to the negative 4 plus negative 3, negative 7. And then multiplying 1.06 times 1.05. 1.113. Does that need to move any? No, it's already in scientific. So you don't have to move it.
Zero or bigger than 10, you can't do it. You have to move it. That's
exactly right. .5 times 10 to the 8th, all of that squared. Okay, that'd be 10 to the 16th. What about the 4.5? Does it stay the same? What do we do to it? Yeah, square it. 4.5 squared. We get that number. $20.25. Move it which direction? All right, so the rule for this is that the exponents multiply because it's parentheses, the exponent outside. So we're multiplying. The exponent on the 10 is 8 times 2 is 16. And then there's technically a 1 exponent on the 4.5, right? So 2 times 1, that makes it 4.5 squared. Right there, right? And when I square 4.5, I get 20.25 by just working out this number. Got to move that decimal to the left one place. What's it do to the exponent? Plus 1, right? So 2.025 10 to the.
So the number on 10, that is the exponent on 10 doesn't matter, right?
What do you mean?
Like, it doesn't affect. So that one it can go over 10, right?
Yeah. The exponent on the, there are no rules for the exponent on the 10 as far as how big or small it could be. Only the number that's in the front is the only one that's got that rule. So we had 1.5 times 10 to the negative 6 to the third. Ten to the what? Negative 18, good. 1.5 to the what? Third. We just need to work out what's 1.5 times 1.5 times 1.5. Is it 33.75 or 3.375? All right, so do we need to move our decimal? No. You won't have to do that on every problem. So don't get thinking, I got to move the decimal every single time. You don't. Sometimes you do, sometimes you don't. You got to recognize when you do and know that if I move left, I add to my exponent. If I move right, I subtract. That's the rule on that, okay? All right, so that's multiplication. Do multiplication, then guess what we got to do next? Dividing. The good thing is when you divide, the rules are still the same, okay? As far as how you do them, other than the exponent rule. What's the difference on the exponent rule when you're dividing? You subtract them. M. So if we had 1.2 times 10 to the fourth over 1.6 times 10 to the negative 3. Subtract the exponents on the tens. So 4 minus negative 3. I heard negative 7 and I heard positive 7. Yeah, 4 minus negative 3 is double negative, so that makes a plus. So it ends up being positive 7 on that. Be careful on your signs there. And then the numbers in front, we're going to divide 1.2 divided by 1.6. Like just regular old, how much there? 0.75? 0.75. Yeah, that's right. 0.75 times 10 to the 7th. Is that in scientific notation? No. So what do? To the right, one place. What am I going to do? Subtract 1 off the exponent. Good job. 7.5 times 10 to the 6th. The division doesn't get any more complicated. I mean, it's just those rules. Subtract the exponents, divide the numbers in front, fix it if need be. Okay. Same way with multiplication. Divide, multiply the numbers in front, add the exponents, fix it if need be. You won't have to fix every one of them. You will have to fix some of them. Okay. So our practice today is on page 515. 3 through 47, the odd ones. That should get you enough practice here on this and get you going with scientific notation. Easy thing. Hopefully you understand a little bit better than you have in the past. Yes, ma'am. Yeah. Hang on just a second. Let me